So, last class we discussed about the SPDF blocks and trends in atomic radius and ionic radius. So, what are these trends? Trends means the general features shown by group in period. If we check a group, there are set of elements. If one element is showing this property, we can see a general trend in the periodic table, because we know that atoms are arranged in the periodic table in the increasing order of atom number. So if one element is showing a trend, we can see a variation in the trend in the periods and groups. So what will be the physical properties and physical trends? So there are 5 category. We discussed atomic radius and ionic radius in this. So the other 3 we are going to discuss in today's class. Those are ionization enthalpy or ionization energy, electronegativity and electron affinity. So let's see one by one. These terms are new to you. I hope electronegativity you may know, but ionization energy and electron affinity new to you. So let's start. So what do you mean by ionization energy? Ionization. What is that process, ionization? So ionization energy is the minimum amount of energy required to remove an electron from the neutral gaseous atom to form an ion. It's really simple. Actually, we know the atom. Atom in the ground state, it is neutral. It has no charge. We know in order to attain the stability, it needs 8 electrons in the valence shell. So what will happen? Some atoms doesn't have the 8 electrons in the valence shell. So for the stability, they are ready to donate or accept or share electrons. So what will happen is, if for stability, for donating or accepting electrons, it needs some energy. So the amount of energy we have to apply. So the amount of energy which we are applying to remove an electron from the atom is known as ionization energy. For example, if you take sodium, its atomic number is 11. So its electronic configuration is 281. So if we apply a minimum amount of energy, the one electron of the valence shell will remove easily. So the atom of sodium became an ion, that is cation, because it is donating an electron. If we donate something, we will get positive charge. So the sodium atom converted to sodium ion. So we are applying, or we are providing some energy. This energy is known as ionization energy. So we can define the ionization energy as, ionization energy is the energy required to remove an electron from gaseous atom. So we can define it is in many other ways. It is the amount of energy required to overcome the attraction between the positive protons and negative electrons. We know that in an atom, in a neutral atom, in the center there is nucleus which contain protons and neutrons, and the orbitals, electrons are revolving around the nucleus. So there is a nuclear attraction, because nucleus contain positive charge and electrons having negative charge. So positive and negative always attract. So it is the minimum amount of energy required to break the attraction between positive charge and negative charge. That is, this minimum amount of energy required to break the attraction between the nucleus and the valence electron. So we can define it in many ways. So here you can see ionization, the representation of ionization energy. Here it is the ionization energy, that is the energy we are applying. So here you can see that here so many electrons are there, so many electrons are revolving around the nucleus. It is the nucleus. So it is the energy required. Which electron we can remove easily? The valence electron, isn't it? Because it is loosely bounded, because the nucleus having attraction towards these all electrons, but it is in the end. So if it is in the end, the electrons can easily remove from the valence shell. If we supply some energy, we can easily remove these electrons. So what are the factors affecting ionization energy? That are atomic size, nuclear charge, and one more thing is there, atomic size, nuclear charge, and the screening effect. So let's see one by one. And there are different types of ionization energy. First ionization energy is there. We can denote ionization energy in the form of IE, and it is also known as ionization enthalpy. Enthalpy means energy. So ionization energy, we said it is the amount of energy required to remove an electron from the neutral gaseous atom. So it is the first ionization energy, that is we can denote it by IE1. And there is second ionization energy, that is denoted by IE2. So what do you mean by IE2? It is the amount of energy required to remove an electron from an cation. Because if we are removing one electron, so it became the atom to ion. So it is in the ion form. If we want to remove a second electron again, that became so it is in the form of ion, so that will be more difficult. For example, if we are removing this electron, that is first ionization energy, and if we are removing one electron from this 8 electron in the sodium atom, that is second ionization energy. And if we are removing one more electron from this 8 electron, that is third ionization energy. Okay. Here it is explained, for sodium ionization will be high, since because we know that if we take sodium example, its electronic configuration is 281. If we remove this one electron, its configuration became 28. So it became sodium plus cation. So the second ionization energy is the amount of energy required to remove an electron from sodium plus. So the second ionization energy will be very more, because we know that 8 electrons should be there in the electron to attain the stability. So in the case of sodium plus ion, it having 2-8 configuration. So it has already 8 electrons in the valence shell, so it is not ready to remove that electron. If it is it removes or donate the electron, it will become unstable. So the second ionization energy will be more. So what type of ionization energy does group 1A have? 1A means alkali group in the periodic table. It will be high or low. It will be low. What will be the reason? Let's check. Because if we check down a group, so we'll check the trends in group and period, and if we check the group, we know that from lithium to lithium, sodium, potassium, rubidium, cesium. Lithium to cesium, we said already there are 3 factors: atomic size, nuclear charge, screening effect. If we check from lithium to cesium, what will happen? Lithium having small size. Going down the group, atomic size of the atoms increases. If atomic size increases, what will happen? Atomic radius also increases. If atomic radius increases, what will happen? The distance from the nucleus to the valence electrons will be increases. Isn't it? It is increases. So, if it is increases, what will happen? If it is increases, the attraction of the nucleus on the valence electrons decreases. The effect, that means the effective nuclear charge, the attraction on the nucleus on the valence electron is known as nuclear charge. So the nuclear charge on the valence electron will be decreases. So we can easily remove that electron. For example, if you take a classroom. In a classroom, what will happen? There are so many benches are there. So teach the first bench students. They are sitting nearest to teacher. So the attraction or the concentration of teacher on the first bench students will be more compared to the last bench students. So the last bench students can do some mischievous activity or some naughty things. So it will be like that, isn't it? So what, for example, if we consider the nucleus as teacher, the last bench students as the valence electrons, so the distance between teacher and students increases, so they can easily do whatever they want. But a teacher is strict teacher, it won't like that, but it can do whatever it wants, isn't it? Similarly, the valence shell electrons, what will do if we put some energy or if we give some energy, the valence shell electrons will easily remove. So so if we check in a group, these factors are increasing, what will happen? We need to provide only some energy to remove an electron. So in a group, ionization energy decreases. So here you can see we can easily remove valence shell electron. So the cesium, the last atom having low ionization energy compared to the first lithium. So down a group, ionization energy decreases. So what will happen in a period? In the period, if we check in a period, along a period, what will happen? We know that in a period, atomic size decreases because number of protons increases, number of electrons increases. So the effective nuclear charge on the electrons increases because there is no more addition of extra shells. All electrons are adding in the same shell. Number of electrons increases, same as number of protons increases. So nuclear charge also increasing. The atomic size decreases along the period. So what will happen? The nuclear charge on the last electron increases. So in order to remove the last electron from that atom, we need to supply more energy. So if we are moving left to right, the ionization energy increases. Okay. So this is the ionization energy. Then we'll move to the next. What do you mean by electronegativity? Electronegativity, here you can see. Electronegativity is the ability of an atom to attract shared pair electron towards itself. It is the ability of an atom to attract shared pair electron in a bonding. For example, if we check any covalent bond or ionic bond, it is made up of two different elements. If two different elements having different charges and different number of protons, different size and all those things. If an atom having more electronegativity, it will attract the shared electrons. For example, in covalent bond, if you check, it is for example HCl. The Cl is more electronegative. It means that it has the ability to attract the shared pair electron. That is, the sharing of electrons are there in the covalent bond. So in the middle there are electrons. So it has the ability to attract the shared pair electron of both chlorine and hydrogen towards itself. So it will get partially positive charge, partially negative charge. The hydrogen will get partial positive charge. The chlorine will get partial negative charge.